I was confused about the logistic regression part. That how do we apply the class weights given the codes that we have practiced so far in module 3 and for exam as well? So I was a little
That's a good question. Um, so let me say this: as you probably know at this point, the class weights that are used to adjust the cost function, which is a one of the alternative solutions to deal with the class imbalance problem. The class weights used to adjust the cost functions are not built into the logistic regressions and Adeline and the PML models, MLP, multi-layer perceptual model, MLP models that are practiced so far in the class. So that means using the algorithm. Can you unmute? Can you mute yourself if you have background? I'm answering a question by Anand. Thank you. So as I was saying, the algorithm that are practiced so far, the several models, they assume the data set has fairly equal balance between the two classes, true and false, not true and false, positive and negative. So even if the classes are imbalanced, if the data set has imbalanced classes in the target variable, the algorithms that we practiced in class do not have a mechanism because we are basically starting from scratch. We started from scratch to make those models happen. And in order to embed a capability to deal with class weights and to adjust the cost functions as well as model performance evaluations, you would have to have more advanced, I guess, tweaks or adjustments or modifications to the current algorithm for loops. So the solution to do this, and this is particularly related to the project itself. It's not related to the homework so far. It's not related to the final exam. It's only related to the project. For the project, I encourage you to use the TensorFlow Keras package from Google. And those models have built-in capability to adjust for class weights for the different target classes. So the answer to that is you are not going to use the logistic regression or MLP processes talked about in class for the project. In order to implement the class weights, you would need to use the Keras packages. As you know, I went through the MLP models, the neural network models, or the deep learning models offered by Keras in class. There's we did a particular session and it was recorded, posted on Teams. You can go through that to start, to start putting them together, and then it's only one additional step to include the class weights.
Right. I tried to apply those codes from Keras for logistic regressions, and then I'm getting accuracy for 61%, which I believe accuracy. So to improve that, do I have to do something with the variables because I've already converted all the variables to binary? through one part
Mm-hmm.
encoding, and I'm also taking care of regions. But even then, my
Yeah.
accuracy is 61%. So I was
Okay.
confused, like how to improve that.
So 61%, I don't know. Typically you would be able to get to 70, 78 accuracy. If you're looking at accuracy, then I would say it wouldn't be too hard to get to 77 or 78. And um, if you're only getting 62, I don't know, 62. Okay, so uh, two stories. If you have not put in the class weights, it's easy to get to 77. But if you have included the class weights, meaning you have adjusted for the sensitivity of the model to different classes, then your sensitivity will drop. Not necessarily, your accuracy will drop, even though your model may be improving. And here's why. Remember we talked about many model evaluation metrics in the
Yep.
module X. So at this stage, I would expect you to take into account those different metrics rather than only focus on accuracy. Why? Because those model evaluation metrics exist for a purpose. And for different situations, for different business problems, um, sometimes you use a different set of metrics to evaluate the models for this problem. Currently, it's binary classification, and you have a class imbalance problem. If you have taken a look at summary statistics, the positive label is maybe only 22 or 23% of the data set, whereas, or maybe 28, I don't remember exactly, it's either 22 or 28. The opposite side of the majority class is either 72% or 78%. So without using the class weights, your accuracy will be capped at that majority class because model tend to predict everything in the same class label, which is the majority case. So in that case, what does that mean? Your accuracy is capped at the majority class weight, and then without putting a weight to your model, right? The majority class weight, what I mean by that is the percentage of the majority class in the sample that's in the data set, that's 78%. Your model predicts negative for every case. Model learned that trick. You know, which is a challenge. You need to counter that force. But a model will tend to find that trick and predict everything the majority class. In this case, think about what the recall will be. The recall will be 0. Sensitivity of your model will be 0 because for the 22% of the positive cases, the model is picking up none of those. So recall is 0. Specificity is 100% because all the negative classes are being correctly predicted. So if you take recall to try to calculate F1 score, you are going to get either an undefined F1 score or a 0 F1 score, which is poor. So this means that the model is not doing well by predicting it all using the negative class label, even if the accuracy is not bad, 78% is not bad, but you need to look under the hood and beneath the surface to recognize really what the problem is. Now, if you have put in the class weights, then your model is going to predict some positive and some negative. So for some of the true negative, so some of the negative outcomes, which is the true labels, the model will make some false positive errors. And then for your model is not going to pick up every positive cases because it's still tilted toward the negative classes. So it's only going to predict some positives. It's going to miss some of the other positives. So it will make continue to make false negative mistakes. If you put them all together, your accuracy may even drop below 78%. But at this point, your model is going to make some progress on sensitivity, meaning your sensitivity is not 0 anymore. You are going to correctly hit some of the positive outcomes with a non-zero sensitivity or recall, and then a non-zero precision score. You are going to have an F1 score that is not undefined. At least it may be in the 0.3, 0.4, 0.5 region, which is a considerable improvement from a model that doesn't consider the class weights and tend to predict everything as negative, right? So you need to recognize that. If you are getting an F1 score not so high, let's say, close to 0.3 or 0.35, 0.4, or not above 0.4, below 0.4, that means model has room for improvement, mostly in the sensitivity score. Your model has room to improve, but it is sort of like an endless journey. Make as much progress as you can, and then wrap up your report, wrap up your work. During the final stage of your work, if you are able to get your model out of the trap, by the trap, I mean the model tends to make everything, to make predictions for everything as negative. If your model is able to get out of the track, then you're on the path, on the right path. Even though you may go so long to try to get your model as having an F1 score close to 0.7 or 0.6, but you're going in that direction. If you don't have time left, it's okay. Summarize the progresses that your model have made and analyze how much of an improvement has it been. You need to discuss those other metrics. You need to discuss sensitivity, which is recall. You need to discuss your confusion matrix. How were you able to improve your model in the sense of false, first of all, sensitivity, you're able to improve dramatically. Precision, the model used to not predict any positive. So precision, as your model starts to make some positive predictions, precision also improves. So F1 score improves dramatically from undefined, right? And beyond these, on the false positive and false negatives, calculate those metrics from your model and discuss how much of an improvement was it before compared to the model before that, and then wrap up your model evaluation results, and then use the last model that you have trained or have reached to make predictions on the score set. Right? This is not trivial work. Let me say this, and this kind of takes quite some time to experiment and to, make sure your code will work all the way until you can make predictions using your Keras model that is trained with the class weights adjustment. So before you kind of, dive into all of these, you want to make sure that your data pre-processing is all done well, and then you have a way to pre-process your score set correctly, because even if you train a perfect model, if you cannot work through the scoring process by pre-processing the score set and then apply the model to the score set, then you're going to, stop shy of the final step. So make sure your pre-processing stage for both the training set and as well as test set, if you have test set, I believe you have, and the score sets. Make sure you have those prepared, and then work on continuously improving your model by using those different metrics, and then stop at the point that you don't think you can make substantial improvements, and then stop when you don't have enough time, when you don't have much time left to wrap up the study, and then wrap up. Write your report nicely, and in a comprehensive way, and then submit your work. And that, even though that doesn't feel like it's a complete, even though it doesn't feel like it's a perfect project process, but let me assure you, every real life data science project feels like that. It feels as if there's never a period there. You never feel there's a period because the model continue to have some room to improve, but it's more and more challenging to improve, and sometimes it even backtrack. It feels like there's this progress there, but the real life project feels like that. So don't be, try not to be bothered by that, by an imperfect ending, but you're actually closer to, being able to complete real life projects by going through this process. All right, that's a long answer. Let me hear what other questions you might have.
So, Professor, I tried to generate a classification report. So in that, I have two F1s, two recalls, two precisions for for 0 and 1, both possibilities. So I have to
For both
for both of like for 0 and 1, both possibilities, like positive
for
possibility
0
negative.
and 1
Yeah.
possibilities.
Yeah.
Okay. Yeah, because you have two columns in your target data set, right?
Right.
And you use
So
neural network.
yeah.
Yes. So what's your question?
So I have to follow the positive for all the explanation that you just gave for F1 score and recall. So I have to follow the numbers for the positive outcome for 0. Like for 0, I have
Is that your
F1 score.
question? Your question is which side of the prediction
Yeah.
you should use?
Mm-hmm.
Okay. So let's say this is actually similar to the way the predictions are generated by the MLP algorithm used in the classroom, even though that MLP algorithm doesn't include the class weights. So what happens is in your Y training set, you have two columns, and it's always 0 or 1, right? In your training set, or as well as a testing set, your target data set, Y data set, always has two columns, one representing a label for, one representing whether or not label 0 is the true label, the other representing whether label 1 is a true label, and the values are 0 and 1. But the MLP model that we trained in the classroom, the output, the activated value, we call activation value or activated value of the output layer, it outputs two columns as well. And it outputs the probabilities of that label being the true label. So let's take an example. Let's take one row of that activated value matrix from our MLP model. Let's say one value is 0.3. The other value is 0.5. The first value, 0.3, is the likelihood of that negative label being the true label. The predicted, the confidence of predicting negative label is 0.3, the confidence, the likelihood. The other let's say 0.4 is the likelihood of, or the confidence of predicting the positive label being the actual outcome. So even though neither of these is above 0.5, but you take the higher likelihood. In this case, the higher likelihood is associated with the positive label. And that's why we use the numpy.argmax. Argmax will return the label of the higher likelihood column, right? So if you compare 0.3 versus 0.4, 0.4 is higher. And the argmax will return the label or the index for the second column, which is 1. The first column index is 0, and that corresponds to the negative label. Index 1 corresponds to the positive label. So in this case, our algorithm will tell us that the predicted class label is positive. Right, so using one example to illustrate, I think with using Keras, you can again use argmax. If I'm not mistaken, you can use argmax to return the label, and then that becomes a predicted class label for this case, and then you can do it for all the cases in your score set. So you actually use both columns results instead of using just one of them. Hopefully that makes sense.
Yeah, thank you.
Mm-hmm. Any other questions? Yeah, don't be shy. If you have questions you want to ask right away. Even if your teammate is not here, if you expect him or her to be here, but he's not here, everything's recorded. So go ahead and ask your team's question, and later your teammate can review the video.
I have one more question, Professor. Sorry, it's just me asking the questions.
Sure, no worries. This is the purpose.
Is it okay to have, can we have a higher precision, like as high as 94% and with accuracy of 61%? F1.7, recall 0.56.
F1, can you repeat that?
Precision is 0.94.
Precision 0.94 is pretty good. When you predict positive, 94% of those are true positives.
Recall is 0.56.
Recall
F1 is
0.5, 6 close to 0.5, or close to 0.6, which means 60% of the positives are being correctly recognized. And
F1 is 0.7.
F1.7, not bad, not bad. So I can't say this is the best model because there's always potential for better. And sometimes when you increase one metric, the other drops. So there's trade-offs here because it involves a false positive and false negatives as the model is adjusted. So your task is not to try to just get the positive, get the perfect one. There's no perfect one here. The correct answer would be whether or not you think this model compared to where you started is improving, how much of an improvement, or if you have 3 different versions along the way that you have obtained from training the models. How do you recognize whether or not the model is improving? In what sense? Here the issue is imbalanced classes. That's the biggest issue here. So against that issue, compared to a model that tends to predict everything negative, which of these model seems to be working or seems to be improved the most? And then, analyze this, analyze your statement by using the metrics that we talked about. Overall, F1 score above 0.7 is truly not bad. It's great. Assuming you have trained several versions, you want to discuss the improvements along these different versions and apply the same kind of analysis what we talked about.
I haven't practiced different versions of the same by applying the same codes, but I have tried to implement logistic regression using different codes. So different formats.
Okay.
So from other formats, I'm getting accuracy of 81%. But for this model, I'm getting an accuracy for 61%, but all other parameters are good. From Keras, I'm getting these results. So I'm confused which models to refer to. And do I have to keep all these models in the project, or I can discard the other ones?
Well, I mean, if you only train 2 so far, you probably want a couple more to help you understand what is leading to the changes in the results. But if you have trained different ones, you don't have to keep all of them. So that's basically my suggestion. Also, in your reports, in your deliverable, which is just one, Jupyter Notebook file, in your discussions about model evaluations or model comparisons, I will anticipate to see your discussion to talk about not only accuracy and F1 score, but the underlying metrics as well. We have at least sensitivity or recall, we have precision, and the ones that you talked about, and then compare the models along those metrics, as well as on the overall, the most prominent metrics, which is F1 score, and you also mentioned accuracy. In this particular problem, I would expect to see that you recognize that accuracy is not the best metric to judge between models, because some of the models that seem to have the highest accuracy, such as 81% that you talk about, that model likely only predicts negative cases. And that's clearly not a good model. And then, the clearest or the most obvious way to judge that is not a good model, even if the accuracy is over 80%, is because that model achieves zero sensitivity. A model achieves zero sensitivity is never a good model, right? And then also, if you look at F1 score, that model doesn't have a good, or even F1 score is undefined, right? So from those aspects, you know that the model with the highest accuracy is not necessarily even a good model, let's say the best model, right? So here the best model is, which the model you believe is the best model, and state the reason why by using basically the same principles that we talked about throughout this session.
Right.
Mm-hmm.
And for the cost values, if we are getting NaN, so for out of 10 values, I'm getting NaN for 2 values. So, and because of that, I'm having a broken graph for logistic regression. So I have not been able to identify the issue.
You mean when you try to plot the cost curve, you're not, some of the values are undefined?
Yep.
Really? That is not something I've heard. But so it says infinity?
Yeah.
Really? Okay. Could it be that the model just needs more iterations to more epochs to converge? If you, what happens if you, try trying the model for, let's say, 50 more epochs? Because with Keras, you can easily do that. And then, retrieve the cost values and then make another plot and see if it tends to stabilize. A model that has a large percentage of undefined cost values is overflow, numeric overflow. That means the training process is not stable yet. So you probably want to be able to observe a stable cost curve before you reach a conclusion.
Okay, thank you.
Mm-hmm. Any other questions? Does that mean most of you here have already completed the project?
No, but I just wanted to listen in to other insights.
Mm-hmm. Mm-hmm. What are some of the challenges that you have experienced so far and you're still working?
So far just like a lot of debugging with errors.
Okay.
So we're
Okay.
just kind of working
It
through those, but we're slowly getting them one by one. So I think we're okay. But I just kind of wanted
okay.
to
So
see what
you're able to
questions.
work through them as they emerge. Sounds like that's what happened, right?
Yeah, so we would type it and then we'll get an error and then we would like look at it. But it's been like a slow process. So slow
Mm-hmm.
process, but we're getting there little by little.
Okay, I understand that, and it's great. I praise your team for being able to analyze or understand the deep the error log and be able to work through and find solutions to those. These are precious skills. This is I mean proper even if not more important than the concepts that we talked about, the model evaluations, tricks or not, but these are, I would say, as important as leave the class and work on real life projects. Let me ask you, those errors, are they mostly related to data cleaning or the EDA process, or is it more related to the training processes using the Keras model?
Mostly EDA.
Mostly EDA, so data cleaning, understanding, massaging, those stages. Okay, okay, I see. So given that the project is due tomorrow, um, my suggestion for your team is that um, when you, so here is the insights that have emerged from the questions that I got on Teams, and also the questions that Anand talked about. But Anand here is more progressed, I believe, in that they've already trained models with by adjusting the class weights problem, and then so her question didn't really expose the issue here. The challenge with training neural network models using the data set for this project is that the class weights are imbalanced. And this is not something that the class has spent a lot of time on. The course so far has spent a lot of time on the modeling frameworks, the several classic models, and the modeling frameworks, and understanding the processes by opening up the black box. So that is what the course has mostly focused on. Class project, this project, lets you practice all of those. But also, 1 second, can you ask Mom? But I don't have time, sorry. Okay. Anyway, sorry. So I was talking about the challenge in the project. So the challenge in the project not only includes the managing the complete process that we went through in the class, but also the additional challenge is that the class weights of the two classes, the proportion of the cases in the proportion of the two cases in target variable is imbalanced. The level of imbalance is beyond a threshold that was typical in the class activities so far, the homeworks and some of the exam questions. The balance is so severe, 1 to 4, basically. 20% is the minority class, 80% is the majority class. The class imbalance is so extreme to the point that it tends to trap the model, so that the models that we use, the algorithms that you use in the class activities, those models that we program by scratch, those models tend to be trapped, such that it tends to make all predictions as the majority class. So that's, obviously a problem when it comes to the more nuanced model evaluation metrics, such as sensitivity and in this case it's sensitivity, and in other cases it's the what's the specificity. So when you have trained your first model, when you look at the accuracy, it may be okay, it may be good, but immediately go beyond accuracy to look at the more nuanced metrics that we talk about in Module X, such as sensitivity or recall, and precision. Before precision, you want to look at the confusion matrix. You want to calculate the 4 cells of the confusion matrix, and then put the confusion matrix together, and then look at sensitivity and also false positive and false negatives, and then F1 score. F1 score is the ultimate, sort of the comprehensive measure for model evaluation. Take a look at those and then evaluate your model. You'll realize the problem that we're talking about here. At that point, you want to then look into adjusting the class weights to counter the negative influences of the imbalanced class weights. It's a simple implementation by adding one parameter in the model fitting process. And then based on your EDA process results, which should tell you the percentage of the positive versus the negative classes, use an inverse of that fraction to counter the balance by setting up the class weights of the target classes. And then that would be your next model. That will be your second model. After you train that model with the adjusted class weights, take a look at those same metrics that you looked at for your first model, and then compare and see how, how results has changed just because you have implemented the class weights adjustment. At that point, if you don't have time more left, then you can wrap up by choosing which model you should go with in making predictions on the score set, and then make predictions, prepare your final scored data set, and then submit your work as well as the Drupal notebook. So this is, I'm talking about this in case you have a, short time remaining to complete the homework, to complete the project without necessarily having to go overtime and submit your project late. So this is my suggestion for sort of like the recipe for quickly converging on, how to deal with the class imbalance problem in the project dataset. So that's my suggestion. If you have more time, of course, you should explore more, like what Anna is doing.
Hi, Professor.
Mm-hmm.
I have a questions about my my final result. So I ran two models, and then I picked one of them to be the final models, and then I tried to run it on the score dataset, and the result is kind of funny because I got all of them as 0. So is that the final model is not a good pick?
So, how do you judge if this model is a good or a poor model? You would probably start with accuracy. You'll calculate accuracy, but accuracy is not bad. If it predicts everything as 0, which means negative outcome, negative label, accuracy is fine. But since we have talked about more model evaluation metrics, you should also look at the recall, false negatives and false positives, and then as well as the confusion matrix, and then look at F1 score. And by that point, you will see that a lot of these are 0. And a model has a lot of these metrics being 0 is not good, quite clearly, right? And then you analyze what the problem is. Well, why do they have a lot of those metrics being 0? It is because the model is not predicting anything positive. A model that is not a model that does not, or a model that is not confident to predict anything positive. That means the positive label on the positive classes, the model have not learned too much information from the data set. This data set with imbalanced class labels is the cause of this issue. This leads to your model not being able to learn too much. So this is what I talked about just now as the first model that you landed. It's not very hard to land on this first model, but the problem is how to go beyond that. You would then look into the class weights. You try to implement the class weights in your model, in your Keras model, and then you will quickly get to a second model. Calculate the same metrics, and then compare the metrics of the two models and try to understand what has changed. So this is a kind of a recipe for this process when you don't have enough time left.
Okay, thank you, Professor.
Well, hopefully it makes sense. If anything doesn't make sense in what I just talked about. You know, for sure, ask questions, and then I'm happy to explain, in a different way, or maybe we can do some demonstration, or make some graph here to help you understand.
Professor,
Mhm.
while converting regions into binary, I came across a problem regarding the column names. All the column names were in numbers. So while
Mhm.
applying the model, I was seeing issues. So what I did was I converted the column names to string for the entire data set. Then I got
Okay.
away with that issue. But my column names are still in numbers. So do I need to rename those column names or I can let it be? Because
It's
it's not causing
strange
me any
because
issues.
if you're using keras, then the outcomes or the outputs of the model, you were talking about confidences. Confidences for the negative and the positive labels as two columns. Those should be in arrays. So those are matrix. Those are matrix. The matrix doesn't have column names unless they are in data frames.
No, while during the EDA process, when I converted the regions column, the categories in the regions column, so all the categories have a numerical column name. So this is
Okay.
what I'm asking about.
So you're talking about data pre-processing.
Mm-hmm.
And so, okay, let's see. You modified the region levels, and how many columns do you end up with after you have modified the region column? How many columns do you have that's related to the modified regions after you modified the region column?
I have 10 columns because regions has
You have
10
you
discrete
have 10.
labels.
You have 10 columns,
Mhm.
and those 10 columns, you have 10 columns. So those 10 columns are looks like they are in one hot format. Those are 0 and 1, right?
Yeah.
So those are already processed,
Mhm.
as in one hot, right? So is that generated as part of the column transformer?
No, I use NumPy where for loop and the NumPy where.
Okay,
Mhm.
okay. Um, are you using uh are you using transformer? I mean,
No,
are you using column transformer?
no.
Okay,
After converting, I
so
just merged
you
the
will
data.
need to merge them uh manually, sort of.
Mhm.
Okay, so if that's the case, your columns, the column labels don't really matter, because before you input your pre-processed data set into Keras model, before you invoke the fit command, you can convert your data set into NumPy arrays. And then the column labels wouldn't matter at all, right?
Mhm.
But when you manually integrate the data sets from different steps of the pre-processing, you want to make sure the column orders are the same between your training set and testing set. That's critical, because your model expects the same column orders. Let's say, for example, your 10 region binary variables starts from the 5th column
Mhm.
in your training set and ends with the 5th, ends with the 14th column. So that's 10 columns. And then you want to make sure that in your testing set, as well as in your score set, the same places from the 5th column to the 14th column, they are the 10 columns for the 10 binary columns for the region levels that you retain, and then the 5th column correspond to the same region level, and the 6th column represents the same region level, such and such. So all those orders and precise positions should be the same across the data set.
Okay.
But the labels, whether or not the label is string or integer, shouldn't matter. You can convert a data frame into a NumPy array, and the label will not have any effect.
Okay. Thank you.
Since we still have some time left, if you would like me to look at your, if there's an error you're still working on, you want me to take a look at your error, we can do that, and maybe hopefully we can quickly solve that. Any other questions?
Professor, can you please brief a little about what you expect in the finals?
Oh, in the finals, you mean, let's say, the kind of questions are very similar to the format of the questions are very similar to the midterm and the homeworks. You can kind of expect that I will give you a data set, or I will simulate a data set, either way. That both has happened in the homeworks. You will be given a data set, and then for the final, because it includes the MLP, you can expect that you will be asked to put together a MLP model given a structure. So I will give you a structure, the layout of the, we call topology, the topology of the MLP model with 3 layers with certain number of neurons in each layer, right? And then this model topology should be consistent with the data set in some way, right? Some parts of the model, based on your understanding of the MLP model, some parts of the model are should be strictly equal to some parts of the data set. This is in terms of the number of input columns. They should be consistent. But then some parts of the model you have control about. So the number of neurons in the hidden layer is something that you have total control. You can specify however many number of neurons you need. So the question asks you to specify certain number of hidden neurons, then you should be able to reflect that in your codes, given the topology graph of the model. And then also for MLP, for binary classification models, you should expect 2 output neurons in the upper layer. Given the structure, you will complete the setup part of the algorithm by specifying those variables, and then you expect to put together a for loop to train the MLP model. And then in the end, you may be asked to make the same graph of the cost curve and then the accuracy curve and or I would say, I think for both training set and testing set, or maybe using the trained model to generate the results for the test set, right? So that is very similar to the literature regression questions. What's also new in the final would be, as compared to the midterm, would be the model evaluations. So you can expect to be asked to calculate, maybe by hand or maybe by using an algorithm, to calculate different metrics, false negatives, false positives, AUC, or maybe precision, these different metrics, right? And be able to read from the confusion matrix. Now, I emphasize that confusion matrix, if you modify the columns and rows, the interpretation is different. In this class, whenever I ask you to interpret the confusion matrix, it always uses the same order of rows and columns. It's always the positive comes first, and positive in the first row and first column. Okay, so these will stick to the same materials in the course. So you have the model evaluation, you have literature regression, and then you have a little bit, I would say a little bit about the unstructured data science, the cleaning, not the cleaning, mostly the cleaning of the text data to recognize regular expression is part of that. To use regular expression to kind of to list out all the instances of string patterns, and then use based on the patterns, you construct a pattern using a regular expression to identify those strings or string sequences. That, I believe, that is the whole scope for the final exam. And of course, the conceptual questions will be kind of embedded into these comprehensive problems. So it's not like one short question followed by another short question, but more, give you a data set and work on it, interpret, explain, things like these. So comprehensive questions. All right, hopefully that answers your question about the final exam.
Yep. Thank you.
Yeah, sure. We only have 1 minute. If I would say if you have questions, reach out to me and to us, to TA, through Teams as well. Continue to do that. I've already received questions so far, and mostly from this panel, though. Mostly from this panel are the questions that I received so far. But I encourage questions from other teams. Don't be shy, as I always say. Don't be shy. Don't hesitate. Send us questions, and we'll help you. I guess currently there's no more questions, and then we can complete this session. Thanks for joining, and then I'm looking forward to help you if you need.
Thank you.
Thank you, Professor.
Yeah.
Thank you.
Yeah.
Thank
See
you.
you.
Bye.